what I call infection is the act of a particular user actually going and telling their friends or referring about it, or their friends getting somehow exposed to the fact they're playing. So the key metric you want to measure is infection rate. That is, for your average new user, how many other users did it actually reach? So things you can optimize there include invite flows, right? You see a lot of apps when you come, say you go to Farmtown, and you always see, send apple or fruit to 20 of your friends every time you come back. That's what you're optimizing. You're optimizing infection rate. And other things that affect infection rate is retention. People come back more often, you're going to invite more people on average. Call to actions, if you ask them to invite, you tend to invite, et cetera, et cetera. And then when you want to optimize past that, the next part of the loop is conversion. So you have a bunch of people, you have people who are inviting 20, 40, 60 friends. Great. If none of them click on the actual request or go to the app, you're in trouble. So what we can optimize there is, this is actually the simplest thing to optimize. It's just a bunch of split testing. So say it does, I really like you, please come to friends for sale, or I like you a lot, please come to friends for sale. Which one converts better? And you'd be surprised at the differences you see from small changes. So ultimately, that is a loop, and that gives you K. And there's a whole nother part, there's a whole nother large chunk of metrics to talk about, which is the engagement loop and how you optimize activation revenue, but I doubt we'll have time. So we're going to stick with the viral loop for now. So if your K is less than 1, meaning that you're not growing exponentially, it actually can still help you, because virality actually discounts user acquisition costs. And if your K is 1, obviously your user acquisition cost becomes 0. And the math is really convenient, actually. So this number represents the sum of how many users you can expect to get after an infinite amount of time, starting with 1 user for bigger K. Right? It's a geometric series. The sum is 1 over 1 minus K. Now, what this means is that if, on average, every new user that comes into your app invites 10 other users, if you paid $1 to get that user, your effective user acquisition cost is actually 10 cents, because for every 1 user you get, you actually get 10. So your user acquisition cost is cost minus 1 minus K, and the discount is actually this K. Meaning that if you have a 0.9K, you can, effectively that's a 90% discount on whatever it is you're paying for a user, which is pretty convenient. If you know your lifetime value, and you know how much it costs a user, bumping the K could make the difference between allowing you to actually effectively at scale buy users versus not. And if you look at how much the top companies are investing in advertising, this is exactly how they're doing it. At scale, it is probably unaffordable to buy 12 million users at once. But it is very affordable to buy 1 million users and get 12 million as a result of it. So how can you optimize each of those things? Well, infection rate. So as I mentioned, viral flows, calls to action, product quality, game mechanics, and allocation tuning. Those are some of the things you can optimize. Conversion rate is mostly thinking about what could persuade somebody to come to an app and engage with it. Copywriting, psychology, and also demographics targeting is surprisingly effective. So some copies may work better for some demographics, female, in different geolocations. And these are the different channels available to you to optimize each of those loops. So on Facebook in particular, you have requests, notifications, reforms, email, profile box, and a bunch more that you can optimize. But I'll just focus on the most effective ones today, I believe, which are forms, requests, and notifications. So this is something I didn't really want to do, but here it is. This is actually a live, this is not a live screenshot, but this is an actual screenshot from our own internal metric system for friends for sale. The data is from June 18th. So what's actionable about this data? Well, one thing, we have these spark lines for a click-through rate. So we know that if that line is going down, either we're hitting some kind of scale we need to optimize, or that copy is getting stale, or the result of earlier split test didn't turn out the way you wanted it to. Another thing that's really actionable is you only have so much resources in a given day. What should you optimize first? Well, you look at what's giving you the most installs, and also, at the same time, how people are distributing. Well, what's the biggest source of distribution for your notifications? So those are probably the largest source of optimization you can do. And for us, if you look, we're getting most of our results from the feed form. So the feed publisher, 17,000 as of June 18th, midday. So that would be the place where we would probably focus a lot of energy next week, and we also, so all of this data is actually drop-in. You can drop in any Facebook app into our system, and we'll pretend we're Facebook, we'll inject links, and we'll track it back, and it just works, which is really neat. But there's some things we actually cannot track. For example, we don't know how many B stories were sent to uninstalled users simply because we don't get the callback. We don't know how many profiles were, well, actually no users. We don't actually know how many profiles were sent because it's users just count profile app.